morning. I am Devasena. In this lecture, we are going to discuss about optocoupler or optoisolator. This topic is present in the subject linear integrator circuits. Optocoupler. The combined package of a LED and a photodiode is called as optocoupler. Using an optocoupler, when an electrical current is supplied to the LED, infrared light is produced and passes through the material inside the optoisolator. The beam travels across a transparent gap and is picked up by the receiver, which converts the modulated light or IR back into an electrical signal. Two parts are used in an optocoupler. They are an LED that emits infrared light and a photosensitive device that detects light from the LED. Both parts are contained within a black box with pins for connectivity. In the phototransistor optocoupler, the transistor could be either PNP or NPN. The figure shows the basic circuit of an optocoupler. Here is the representation of the optocoupler. It has an LED on the input side. This is the LED. A photodiode on the output side. This is the photodiode. The photodiode is connected at the output side of the circuit. The source V1 and series resistance R1 decide the forward current I1 through the LED. This is the representation of the source V1. Thus, LED emits the light. This light is incident on the photodiode. Here is a representation of the light that is emitted by the LED is incident on the photodiode. Due to this, a reverse current is set up in the output circuit. This current produces a drop across the output resistance R2. The output voltage is the difference between the supply voltage V2 and the drop across the resistor R2. So, V out is equal to V2 minus I2 R2. Now, if the input voltage is changed, the amount of light emitted by the LED changes. This varies the reverse current in the output circuit and hence the output voltage. The output voltage is thus varying in step with the input voltage. This coupling between LED and photodiode is hence called optocoupler. As the name suggests, this device can couple the input signal to the output circuit. Optoisolator. Figure shows the typical optoisolator. Here is a representation of the optoisolator. It consists of LED and phototransistor. That is, in the input side we have LED and in the output side we have phototransistor. This is represented in this diagram. When input voltage forward biases the LED, light transmitted to the phototransistor turns it on. Here is a representation of the light that is being transmitted to the phototransistor turns the phototransistor to on, resulting current through the external load. Types of optocouplers. Other than the combination of LED and phototransistor, two more types of optocouplers are available, which are LED photodiode and LED photodiode. Here is a representation of LED photodiode and here is a representation of LED photodiode. In both the circuits, the input current, which is the forward current of LED, results in the emission of light by LED. This light is detected by photodiode and photodiode to produce the output current. The ratio of output current I0 to the input LED current IL is called current transfer ratio, that is CTR. This CTR is different for different optocouplers. Characteristics of optocoupler. The important characteristics of an optocoupler are current transfer ratio, isolation voltage, response time, common mode rejection, VCE max, IL max, and bandwidth. So far we have discussed about the optocoupler or optoisolator circuit. Now we are going to see about IC optocoupler. Optocouplers are available in a variety of packages, the most common being 6-pin mini dual inline package. The examples of such IC optocouplers are MCT2E and MCT2. IC optocoupler MCT2E. The MCT2E is optically coupled isolator consisting of a gallium arsenide infrared emitting diode and an NPN silicon phototransistor mounted in a standard 6-pin dual inline package. Here is the representation of MCT2E optocoupler IC. Features of IC optocoupler MCT2E. The isolation voltage of plus or minus 2500 volts. High DC current transfer ratio. Total power dissipation is 250 milliwatts. Input to output isolation resistance of 1 into 10 power 11 ohms. Low cost dual inline package. IC optocoupler with photodiode. In the 6-pin dual inline package, optocoupler with photodiode is also available. It is shown here. Here is a representation of IC optocoupler with photodiode. It is a 6-pin dual inline IC. Advantages of IC optocoupler. The electrical isolation between input and output circuit. The coupling between input and output is through the beam of light. There is a transparent insulating cap between two elements embedded in the design to permit the passage of light. Response time of optocouplers is so small that they can be used to transmit data in the megahertz range, capable of wideband signal transmission. Compact and lightweight. As signal transfer is unilateral, changing load do not affect input. Unilateral signal transfer means that output does not loop back to the input circuit. The problems such as noise, transients, contact bounce are completely eliminated. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video means kindly share this video to your friends. Thank you.